Hello and welcome. Today we're going to be discussing measures of variability. So, when we last left off, we were talking about that idea of just how consistent, performances were. And so today we're really going to dive into that idea of variability. So, for today's lesson, there's only one main objective. Okay, and that's that you'll be able to calculate the mean absolute deviation and then use this value to measure consistency, okay, within the athletic performance. So in sports, what does it mean to be consistent? And why is consistency so important? So as we discussed a little bit last time, right, most managers would prefer the guy who can go out every day and perform about at the same level than the guy who's unbelievably good one day and then not so good the next day. Okay, so that consistency of knowing what you're going to get day in and day out is something that most coaches and managers and GMs, value to a great amount from individual players. So we're going to take a look at the 2019 passer ratings for Jimmy Garoppolo of the San Francisco 49ers. Okay, so if we look through, there are these 16 data points, one from each game in the regular season. We're going to say, well, was he consistent? Okay, so a passer rating is a rating that has to do with completions to yardage to incompletions and talks about, touchdowns and interceptions and whatnot. But basically, what you need to know is that higher is better and lower is worse. And as we look at this, he has some very low ratings like the 59.8, 66.2, 71.2, 80.2, 80.7, right? But then on the flip side, he has some extremely high numbers. He has the 136.9, the 145.8, the 131.7. So when you look at these numbers, you could say he really had an up and down season as far as using just this one piece of data to look at. So to be consistent, right, means that that individual athlete or as a team, right, they're similar to one another. So some examples of this, if you're still kind of struggling to grab a hold of this, right, a consistent player will score about the same number of points in each basketball game. Okay, a consistent swimmer will have similar times they do each individual event throughout the course of, their season. Or a football, like in football, the running back, right? If they gain around the same number of yards in each game, that would make them very consistent. If every time this running back gets the ball, they're going to rush about 4 yards. You can run them a lot and get a lot of first downs. Okay, now back to these data sets. We looked at these a little bit, very similar sets to these in the past. But this time the data is talking about golfers. I think last time we were looking at bowlers. Both of these sets, the average is right around 200 yards per drive. But when we look at the data sets, right, which one is more consistent? Well, when we look at them, the first group, right, has ones all the way down below 140 and all the way up to over 280. Whereas on the other side, right, there's none that are so low as 140. There are none that are so big as that 280 or 260, 250, right? They're much closer knit, right? Meaning that they are more consistent. Okay, so how can we measure the variability of each individual distribution, right? So we want to look at each point in that. So in the past, right, we've looked at range and we've looked at the interquartile ranges, but there are issues with these, right? Because we know that with the range, we have the problem of outliers, right? Outliers are going to have a massive, right, impact on that range. And when we look at the IQR, right, that only looks at the middle half of the data. That completely ignores the bottom 25% and the top 25%. So you're really only looking at half your data. So we need that individual point variability that I was talking about in the last slide. Okay, so we want to figure out, okay, how can we do that? Okay, so how do we measure each value? How close is it to the center of the distribution, which is known as the mean or average of the values? So that's what we're going to focus on, are those concepts. And to do that, we're going to look at the mean absolute deviation and then the standard deviation. Okay, so these are going to differ from range and IQR, going back to what we talked about before, because we're going to talk about how each point relates to the mean instead of just looking at the data as a whole all at one time. So to find the mean absolute deviation, right? That's what we're going to start with. So first of all, let's get an idea of what we're talking about. So if we look at this data set, okay, we've got 1, 2 2s, a 3, a 5, a 6, or 2 6s, and a 7. Okay, right? There's a mirror image of one another. So there's the same exact amount of data on the bottom as on the top in the same exact spots. Okay, so, right, how far are these points from the mean? Well, the mean is right at 4. Okay, so if we look at this, right, our 3 is -1 away, our 2 is -2 away, our 1 is -3 away. But on the flip side, our 5 is a +1 away, our 2 6s are a +2 away, and our 7 is a +3 away. Okay, so when we look at those, right, the values are ±1, ±2, or ±3. So that means the average deviation away from the mean is just 2. Okay, so what we're going to do is we'll go through and we're going to explain exactly how that's figured out and how that's determined. So don't worry, but just to give you a little bit of visual picture with a small amount of data. So a deviation measures the distance between the observed performance or the observed point of data, right, and the mean of the distribution. So now everything is going to be compared to the mean of the distribution. So to do that, we take the individual performance that they got and we're going to subtract the mean. Okay, the mean absolute deviation, right, is where we're going to find the absolute value of those. So we're going to look at the distance the values are away. And when we think distance, right, distance is positive. So we'll have all positive values. So famous former player and famous manager, Ozzie Guillen for the Chicago White Sox. He was a very polarizing guy. It seemed like players either loved him or hated him. But one of his big concerns during part of his managerial career was just a lack of consistency of his players. So from April 24th, 2010 to May 10th, 2010, May 4th, 2010, and over a 10-game stretch, the White Sox opponents scored the following total number of runs: 4, 2, 4, 6, 5, 6, 6, 12, 1, 7. Okay, and so let's talk about what is the overall variability of this. Okay, so to do that, we're going to calculate the mean average deviation for this distribution. So to do that, the very first thing we have to do is figure out what the mean is. Okay, so when we want to determine the mean, right, we have to add them up and divide by the number of numbers. So if we add all those up and divide by the total number of numbers, there are 10 numbers from 10 games. That's 53 total divided by 10 gives us 5.3. So that's our mean, that's just our mean. Okay, now second, we want to figure out how far does that deviate. Does each individual deviate from their performance? So we take the actual performance from each game and subtract that mean performance. So if the performance is above average, right, we'll have a positive deviation. If it is below average, we'll get a negative deviation. So in this beautiful chart here, you can see for each game, we figured out what the deviation is. So here, right, we were under the 5.3, so we're negative, under, so we're negative, under, so we're negative, over, so we're positive, under, so we're negative, right, and so on and so forth. But like we said, right, we want to get to an absolute deviation, right, the mean absolute deviation. So we need that absolute value because we were trying to figure out how far away it is. If we were to take all those deviations, just add them up, leaving them positive and negative, it would get back to 0, right? Because the number is the mean that we're getting back to. So if you go through, take the absolute deviation, you just make them all positive. So the negative 1.3 becomes 1.3. The 0.7 stays 0.7, right? Absolute value. It's the way it works. So now if I want to find the mean absolute deviation, that means I have to take all of those values. So we're just going to take all those values and add them up and then divide by the total number of values, which we said there were 10 games that we were looking at the data for. So if we add all those values up, it gives us 21, and we divide that by 10, and we find that the mean average deviation for the runs that they allowed was 2.1. Okay, so that means on average, right, either individual performances fell 2.1 runs away from the mean. So now to get an idea, let's compare that to the total number of runs that the White Sox scored themselves over those same 10 games. Okay, so first of all, here's just a little dot plot so you can get an idea of what it looks like. So these are the runs allowed on top, as you can see labeled, and then the runs that they scored. Well, right here you can already kind of see, right? Runs allowed is more spread out, runs scored is closer together. So we're going to expect that our mean average deviation for runs scored is going to be less than the mean average deviation for runs allowed. So let's figure out, is it really less than that 2.1 that we just found for runs allowed? So we're going to have to go through, right, that same exact process that we just did. So we start off with the runs that they scored. So 5, 3, 2, 5, 7, 4, 7, 3, 5, 2. And we're going to make one of the first thing we have to do is find what their mean is. So we add them all up and divide by 10. So if you add those all up, you get 43. You divide by 10 and you get 4.3. At this point, we have to make our little table. Remember, you take each individual game and subtract 4.3 from that. So our ones that are bigger than 4.3, like 5 and 7, right, those are going to give us positives to start off with. Whereas the ones that are less than 4.3, like our 3s and 2s, right, and even, 3 and 2, those are going to give us those negatives. But we can't keep them negative because we're looking for absolute deviation. So then we take the absolute value of all of those deviations, so that way they're all positive numbers, and we add all those together, right, and divide by 10 to figure out what the mean absolute deviation is, right? So when we do that, we add up all those deviations and we divide by 10. Well, that gives us 15 divided by 10, or 1.5. So that means, right, when the two data sets that we just looked at, one has a mean average deviation of 2.1 runs. The other one has a mean average deviation of 1.5 runs. So was our hunch confirmed? Were we right? Well, absolutely, right? They scored at a more consistent rate. Okay, because remember, a smaller number means more consistency. So big numbers when we're looking at mean average deviation means that we're more spread out. Smaller numbers mean that we're closer together. And that's it for today. Good luck on the homework. And if you have any questions, make sure you let me know. Have a great day.